In this video, I'm just going to do a few examples of writing exponential equations using our two forms. Our exponential form, again, is if I'm given the y-intercept, the starting value, the u sub 0. The point ratio form is if I'm just given 1 point from the function and I know the common ratio. Both cases, I need to start off, I need the common ratio. So let's give this a try. First one, I'm just giving you a nice geometric sequence. I give you the starting value, u sub 0 is 8. I know that u sub 1 is 14. The first thing I need to do is find my ratio. And again, my ratio is the current value divided by the previous value. Now I know I can just use the common ratio because I'm given the fact it is a geometric sequence. So I don't need to check to make sure. I know I've defined it as geometric. I can just take this 1 point. 14 divided by 8 would be 7 divided by 4, which would be 1.75. So since I'm given the starting value of the u sub 0 is 8, my function, my formula, is just going to be 8 times my ratio, which is 1.75, raised to the x power. Now, as we're dealing with these geometric sequences, we're dealing with this percent growth again. So we're going to be coming back and using some of that we did in chapter 1. And again, if you don't remember all of that, remember working with finding percent growth, finding percent decay, writing those ratios based on those problems, go back to the Unit 1 folder. I have a video talking about percent growth and percent decay. But in this case, just as a quick remember, percent growth is always going to be 1 plus your percent over 100. So in this case, my ratio is 1.75, and this is actually 1 plus whatever my percentage is as a decimal. So if I subtract 1, I'm going to get my percent is 0.75, or 75% growth. So let's look at my second example. This one, I've given you u sub 10 and u sub 11. So I didn't give you the starting value, so I'm going to have to use that point ratio form. But I still have two consecutive values, so I can still find my ratio the same way, because I have a now and I have a previous. So my ratio is going to be 35 divided by 40, and that's 0.875. So when I write my formula, y equals, I'm going to start with the value I've given is 40 times my ratio is 0.875, and that's raised to the x, but now I have to say x minus 10, because I'm not given u sub 0, I'm given u sub 10. So I have to put that shift into this formula. Now, as I'm looking at that percent growth, give me a little more room to work here. Oh, I left part of the W behind. Oh no. Okay. Percent growth, all of this isn't growth. Let's get rid of that, because how do I know it's not growth? Well, my ratio is less than 1. I'm going down 40 to 35. So this wouldn't be growth. This is going to be decay. So decay was 1 minus a percent. So my 0.875 is 1 minus some percent. So I'll subtract my 1, and I get a negative 0.125 is a negative percent. So my percent is 0.125, or a 12.5% decay. And again, we want to review some of that material. We went over that in Chapter 1, and it's in some of the Unit 1 videos. I've talked about some of these, so you can look back. That's dealing with the sequences. It's the same way. I'm going to be hitting compound interest as well. Now, the last thing I asked you on this one is, what's the starting value? The starting value would be my u sub 0. I don't have that in my formula, because my formula says x minus 10. So if I want to find u sub 0, that just means x equals 0. So I plug that in. Y equals 40 times 0.875 raised to the 0 minus 10 is 40 times 0.875 raised to the negative 10. Right, what's a negative exponent mean? If you don't remember that from Algebra 1, we'll be talking about that in the next lesson. But fortunately for us right now, the calculator knows what to do, so I'm just going to plug it into the calculator with the negative expression, or negative exponent, 0.875 raised to the negative 10th power, and I'm going to get y equals 152, about 152. So that would be my starting value. Or I could say my u sub 0 is 152. So let's do a story problem. 2012 tuition for Wilkin Academy was $2,000. Tuition increased by 3.5% per year. So to write the equation, I'm given 2012. We have a tuition of $2,000. So my starting value here, I'm looking at u sub 2012 equals 2,000. I have the 3.5% increase, so my ratio is going to be 1 plus my percentage of 0.035. Since I don't have the 0 term, I have to use the point ratio form. So y is going to equal 2,000 times my 1.035 raised to the x minus 2012. To find the tuition in 2018, I'm just going to take 2,000 times 1.035 raised to the 2018 minus 2012. And that's going to be 2,000 times 1.035 raised to the 2018 minus 2012. Gives me about 2,458 and 51 cents. Now, I don't have to do it using these big values, u sub 2012, so I got to plug in 2012 for x. If I'm kind of starting at the year 2012, I can change my starting value. I'm going to make this, rework this problem, and I'm going to call this my u sub 0 in 2012. So if u sub 0 equals 2,000, then I'm saying my x value is going to be years after 2012. So, or in other words, x is going to be the year I'm looking for minus 2012. But if I define my x that way, I mean, my ratio again is going to be my 1 plus 0.035 for my increase as a growth. So it's plus by 3.5%. But then I can write my equation is y equals just plain 2,000 times 1.035 to the x. But I have to remember, what does x mean? So when I get to the second part, I want to say in 2018, x is going to be 2018 minus 2012. And that's going to give me 6. So I can say y equals 2,000 times 1.035 raised to the 6th power, which will again give you that same value, 24, 58, 51. Which one's best to use? It's up to you. This is a little simpler because we just have the x in here. But I then have to define, what does x mean? When I'm using this form, I don't have to think too much of what x means because x is just the year. So I can just plug the year in for x and voila, I don't have to worry about it. It depends on which way you want to do that.